We're at a trout RAS farm in the suburbs of Ulyanovsk. Just imagine, there are 6 hectares of land here. In this RAS system we have 12 fish holding tanks. Generally, RAS can provide full temperature control, and it's possible to achieve year-round farming fry in this incubation department. Well, it's 5 a.m. in the morning, and we're in the city that is famous for 2 timeless things. The first is Vladimir Ilyich Lenin, as he was born here. And the second is rugged, almost eternal Soviet USZ cars. I presume that those who have once been to the USSR remember them. Of course, we're in the city of Ulyanovsk. I think some of you figured out. In fact, there is a lot more to see in the city, but we came here not for sightseeing. Instead, we came to shoot a film about a fish farm, which is located in the city's suburbs around 20 kilometers away from Ulyanovsk. In general, we want to show you how it's possible to combine a RAS and open fish farming in ponds, particularly for trout. Well, let's go! So here we are at a trout farm on the outskirts of Ulyanovsk. Imagine, there are 600 hectares of land here, there are deers grazing here, there are pheasants running around, and in general it's a really picturesque place. It's the beginning of April and we can't see much of this beauty. There is still a little bit of snow, but nevertheless we came to the trout farm. There are 19 large trout ponds which are supplied with water from the springs. The springs constantly supply cool, clear, high-quality water and provide for comfortable temperature in these ponds with trout even in the hottest weather. Just imagine, this farm has 19 ponds. By local standards, this farm has good production volumes and, of course, it needed quite a lot of fry. Well, it's probably easier to buy the fry from the local supplier, stock the ponds with it and let it grow. Why should they think of some way to grow their own fry? But it's not that simple. I think many of us who are engaged in growing fish in open ponds, pond farming, cage farming, know that it's not all that easy with purchased fry. Sometimes it's simply not available, sometimes it's sold for inadequate price. Also, you can buy sick fry. For example, fry that will have low growth rate and that will consume a lot of feed. That's why several years ago, the owner of this site made up his mind to set up his own incubation and fry department. And that is basically how we came to know each other. And now, several years later, we have come to this farm to show how it works from the technical point of view, and to give you an idea of how such a farm operates, as here fry is farmed at a specially designed incubation and fry farm and then is transferred into open ponds. That is, the whole cycle here is not carried out inside RAS, and it's quite common, even classic way. Let's start, of course, with the hatchery and fry department, because that's where it all starts. The area of the building behind me is about 300 square meters, and the RAS system, all RAS equipment required to farm the fry, is located inside it. So it's 300 square meters. Part of this building is capital, permanent structure. Another part is covered with a light roof. You can probably see the polycarbonate. And you see the smoking chimney over there. That's the boiler room that heats this department. By the way, it runs partly on pellets, partly on firewood. Let's have a closer look at the whole system. Here you can see incubation equipment. Fertilized eggs are put inside. By the way, the owner purchases these eggs from abroad. Why? Probably it's not a secret for many that Russia, unfortunately, doesn't have high-quality trout fertilized eggs. Yes, there are a couple of local suppliers, but still 90% of fish farms that grow trout use imported fertilized eggs from Italy, France, America, Finland, and so on. Unfortunately, in this country there are no high-quality fertilized eggs, which you could order in large quantities and which will provide proper growth parameters. That's why the owner of the farm has to import them to incubate in this hatchery. It's a vertical incubator, which basically consists of 16 shelves. The maximum of 10,000 pieces can be put into each tray, and this is according to the manufacturer's technical passport. 10,000 multiplied by 16 trays makes 160,000 pieces of fertilized eggs that we can lay into the hatchery at the same time, which is in principle much more than this farm needs in reality. But I will honestly say the technical passport is certainly indispensable. But basing on the experience of knowledgeable fish farmers as well as my own experience, it's better to put not 10,000 but 5,000–7,000 fertilized eggs into one tray. Therefore, let's be honest, the maximum capacity of the whole incubation unit is around 100,000 pieces at a time. So how does this incubator work? Water enters the top of it, the very top tray. There is a mesh inside, and eggs are placed on this mesh. Water cascades through each of the trays. You see, they're even numbered. And the most important aspect of this incubator is first of all its compactness, and secondly optimal water consumption. That is, the water in this particular incubator is used up to 16 times. So, water overflows from tray to tray and gets a little bit saturated with oxygen, which is enough for the eggs in general, and it brings oxygen to each tray of this incubator. It saves a lot of space, because horizontal incubators take up much more space, so these vertical ones are very often used as incubators for salmon, and in principle, this type of incubators was designed specially for salmon by the Americans. Probably the only disadvantage of this hatchery unit is that in order to control the eggs, they have to be taken out and checked, so you cannot see the condition of the eggs just walking by the unit. You have to check every tray, take it out, actually make sure that all is well with the eggs. If necessary, sort out the dead specimen. All in all, this incubation unit is enough to meet the needs of this farm. Well, imagine, the hatchery occupies only 1 square meter, and it provides the whole farm, 19 ponds, with the required quantity of fry. And of course, this incubation unit is followed by fry farming tanks, but the goal of incubating eggs is reached here, and the whole hatchery occupies only 1 square meter. Of course, our customer has experimented. I will show you now a very interesting and even some kind of unique specimen. A vertical incubator. Homemade. Its operation is based on the same principle. The only thing is that water doesn't cascade here, but is supplied into each tray separately. Thus, this is actually the same incubator. Slightly larger in size, but it performs the same tasks and functions. So here are trays. A mesh is placed inside the trays, the eggs are placed inside, and you can achieve almost the same result using a self-made incubator. These incubators are also designed for 10 shelves, and at least 10,000 fertilized eggs can be put into each of these trays, so we multiply 10 by 10,000, which makes 100,000 pieces in each incubator. There are 2, that is 200,000 eggs can be put here, plus 100,000 pieces in the first incubator that I have told you about earlier. So in general, this farm has high incubation capacity, so high that even these incubators are currently out of operation, because basically the small vertical incubators over there are enough. In general, incubation cycle is carried out once or twice at this farm. As a rule, hatching and ungrowing fry takes place in winter. In spring, the fry is already transferred into ponds, and it's possible to incubate and grow fry in 2 or even 3 cycles per year, as this system allows to fully control the temperature when connected to RAS. It's just not necessary, because stock in ponds usually occurs only once a year, in spring. Since in this particular case eggs are usually placed into incubators at the stage of eyeballs, 1 to 2 weeks are enough in order to get the eggs hatched, so the incubation cycle is very short. And after that, the incubation unit is put out of operation, disconnected from the water supply, and waits for the next cycle. The eggs are incubated at 7 to 10 degrees. As there is a possibility of temperature control inside the system, the fish farmer constantly monitors the temperature and regulates, adjusts it. Usually at the time of laying the fertilized eggs, this temperature is lower, 7-9 degrees, and at the moment of hatching, it's higher than 12-13 degrees. After hatching, the larva gets into these fiberglass trays. These are rather standard trays, 4 meter by meter, in which the larva is kept at a very low water level. Then it starts to be actively fed, and it's fed with live feed. That's artemia. And when the larva is already fattened by live feed, it can be transferred to the dry extruded feed. Now, of course, it's already on grown to the stage of fry. You won't see larvae in the tanks, because in principle the cycle of holding larvae has passed, and trays are already empty. So now all the fry has been transferred to the tanks, sorted, and almost grown up to its final weight. You can see it here in these tanks. Let's have a closer look at the fry. We take this unique net. Doesn't it remind you of anything? And let's try to catch some fry. Here are trout fingerlings, 5 to 7 grams, which in principle will soon be ready for transferring to the open ponds. As soon as it gets a little warmer, it will make sense to transfer the fry there. Well, I release this fry into the water and let's go on. At the moment, the cycle of fertilized eggs incubation and larva holding and ungrowing has already passed at the farm, since it's April, so all juvenile fish is in these tanks. It has already reached the weight of 5 to 7 grams. We have 12 tanks here now. The volume of each tank is 3 cubic meters, and 3,000 of pieces of fry are inside each tank. We multiply by 12 tanks, which makes 36,000 pieces of fry. They are inside the tanks at the moment. I have already mentioned that this farm is supplied with water from the springs. The springs supply large volume of cold water to the farm and all year round. So, here is the question. If there is so much good quality water, why is RAS needed at all? Let me explain. Because in principle, in RAS you can provide complete temperature control and year-round ungrowing of juveniles inside the fry department. And you can get fry several times a season, not depending on climatic conditions. And over the winter, when water in the springs is too cold and the fish doesn't grow, you can farm strong, healthy juvenile fish and up to the required weight. And in the very early spring, release fry into open ponds at a weight you would have never got growing it in a flow-through system. Well, let's talk about the technical parameters of this system. I have already told that there are 12 tanks, 3 cubic meters each, if all of the tanks are being used, and the total volume of water in the tanks is 36 cubic meters. Water exchange in this system is about 1.52 per hour. Pumps are pumping about 60 cubic meters of water, so in principle it's enough in order to timely supply tanks with oxygen and remove all impurities and suspended solids. So the total water volume is 36 cubic meters, and water exchange is 60 cubic meters per hour. Now there are 36,000 pieces of fry inside the tanks. They weigh from 5 to 7 grams, and generally you can safely grow up to 50,000 pieces weighing 20 grams each in this system. Let's have a closer look at water treatment units at this RAS farm. From the fish holding tanks, the water flows through a pipe. This is 200 mm diameter pipe, and it's connected to the drum filter. This is the drum filter. It filters out all the basic mechanical suspended solids. Fish feces, remains of uneaten feed. Water gets inside the drum, is filtered through a special micro mesh, and treated purified water is thus discharged from the drum filter and flows to the further treatment units. In order to flush the drum filter mesh, a flushing pump is switched on, and it automatically pumps water at high pressure to the nozzles. Then from the nozzles to the mesh, and thus water flushes all the suspended solids into the drainage system. In this way, this filter operates in fully automatic mode, and it traps all suspended matter on its mesh. Well, we have treated the water from mechanical suspended matter. But what next? Water gets further into the biofilter, because there is still ammonia nitrogen dissolved in the water. And it's toxic to fish, so it must be removed from the system. And ammonia nitrogen is removed from the water by means of a biofilter. Firstly, it decomposes it into nitrites and then into nitrates. This is a moving bed biofilter. Probably nowadays it's the most commonly used technology. The concrete channel is divided by partitions into chambers. It contains media, plastic pellets, and special nitrifying bacteria get stuck to it. These are nitrous ammonium nitracebacter. They treat the water from ammonia nitrogen. At the bottom of these channels there are diffusers. These diffusers are fed with air from a blower under high pressure. In this way, the media is constantly in motion. And the blower supplies oxygen to the water and the bacteria, so that effective water treatment from ammonia nitrogen is guaranteed. After the water is biologically treated, it's collected in this pump tank, which is also made of concrete. The pumps from this tank take the water and deliver it to further treatment units. To be precise, these are 3 kilowatts, low-pressure, German Willow pumps, which pump about 100 cubic meters per hour at low pressure. So on the one hand, the oxygenator units can operate well, and on the other hand, the energy consumption in general can be minimized. Let's now talk about the utility lines at this farm. Where is water supplied from? As I have already mentioned, water is supplied from springs. It's cold, supplied all year round. It's high-quality water and its volume is not limited. So its supply to this farm is heated and gets into RAS. Heating at this farm is provided for by means of a pellet boiler. What are pellets? Basically, pellets are chippings compressed into pellets. The pellets are delivered in bags, poured into the boiler bunker. The boiler operates automatically, consuming the pellets and maintaining the required temperature at the farm. All in all, it's one of the most wonderful sources of heating nowadays, and in my country, if there is no main gas. It's cheap and semi-automatic, but it saves a lot of money and is generally environmentally friendly. Sewage. As the site area is vast, with a huge number of ponds, the sewage of the incubation and fry departments is rather simple. The wastewater is simply being discharged into one of the ponds. As the ponds are large, the volume of the discharged water is not damaging the environment. And the ponds are located on our client's territory, on the site. So even if the wastewater is discharged into these ponds without preliminary treatment, the environmentalists will have no claims, because the owner of the farm has all the rights to discharge wastewater within his own territory and the way he wants. Ventilation. Ventilation is a draw-in or supply, that is, it's forced air supply. Ventilation ducts are located at the reach of the building. The air is forced in by a ventilator, and it's vented naturally through windows, doors, or rather natural exhaust. Let's see what period of time the fry is being grown in RAS. It's very simple. Now it is the beginning of April. Larva was transferred to these trays in January, which means that the eggs were laid at the end of December. It turns out that January, February, March and April, 4 months. Just at the end of this month, fry will reach the weight of about 10-15 grams, and it will be transferred into ponds. One cycle of growing juvenile fish takes 4 months. This means that in principle, 3 generations of fish can be farmed in 1 year if the system is in operation all year round. Now let's talk about the staff of the farm. How many people work here and what do they do? Since the fish farmer's functions are not limited to monitoring the operation of incubation and fry departments, but also include controlling all the ponds, he spends only half of his time here and the other part on the ponds. Well, and there are 3 operators who are continuously shifting a day or 2. Thus, there is 1, maximum 2 people at this farm round the clock. What do they do and what are they responsible for? It's very simple. Firstly, they feed the fish. Secondly, they keep an eye on the equipment. Thirdly, they monitor all utility lines so that there are no failures in heating and water supply, so that the required temperature is maintained inside the building, water is heated, boilers operate properly, and in principle the whole infrastructure functions normally. And of course, they help the chief fish farmer, the biologist, in some of his fish farming activities, for example, to sort the fish. So in fact, they're the right and left hands of the fish farmer. So we have got the fry. What should be done further? It's very simple. There is a gate at this farm. It opens. A car with live fish containers approaches this gate. The fry is transferred into these containers, driven to the ponds, and then released into the ponds for further growing. That's why these incubation and fry departments operate only part of the year, although it has potential to operate all year round if the fish is transferred to the ponds. And also, it's possible to farm fry for further sale. This is Anton Pelcher. If you liked this video, press the like button and subscribe to my channel, the channel on how to grow fish and earn good money from it.